take a look at, let's do number 4. The sine of 5 pi over 3. And it says you need to use the double angle identity, which means is 5 pi over 3 double another angle that's already on the list? And you can see that inside the formula sheet. So if you look at the double angle formulas, it says the sine of 2 theta is equal to 2 sine theta cosine theta. And in every one of these formulas, theta must be known and 2 theta is desired. And I know it's kind of backwards from what you want it to be, and it's confusing when you work with double angles and half angles, but the double angle formula says if you know a theta on the unit circle and you double it, you can create that answer using the original angle. So all we need to have the sine of 5 pi over 3 is ask what angle times 2 is 5 pi over 3.
50 degrees.
So how do you cut a fraction in half? Double the bottom or cut the top in half. So how do you double a fraction? Times the top by 2 or divide the bottom by 2. So is there a fraction where you either cut the top, you double the bottom or cut the bottom in half, double the top or cut the bottom in half that equals 5 pi over 3? 5 pi over 6. So we are going to say the sine of 5 pi over 3, or you can change it to degrees. That's fine too. Yeah. Well, what is 5 pi over 3? 300. So that would convert down to 150, and this one would convert down to 5 pi over 6. Okay? So if you want to know what 5 pi over 3 is, all you have to do is take 2 times the sine of 5 pi over 6 times the cosine of 5 pi over 6. Now, you're going to ask, wait a minute, 5 pi over 3 is already on the circle. I already know what the answer is. If you look at 5 pi over 3, the answer for the sine is negative root 3 over 2. Yes, what we're doing is practicing the formulas. That's what we're learning in this chapter, is how the formulas work. So, I look at 5 pi over 6. The sine is 1/2, and the cosine is negative root 3 over 2, and all of this is times 2. So what is 2 times 1/2 times negative root 3 over 2? This cancels that, and there's the answer. So this equals that. That's what we just did. Okay, you want to do number 2? So it's good to see the tangent. There is a tangent formula on your worksheet. Cross it off. Don't use it. You need to remember that sine over cosine is tangent. So essentially, if we want tangent of 60, we really want the sine of 60 over the cosine of 60. And we need to use the double angle formula. Is there an angle that can be doubled to equal 60? 30. So we're going to take the sine of 30, this is equal to 2 sine 30 cosine 30. And what should we do for the cosine of 60? Well, there are 3 choices. We can either do cosine squared minus sine squared, or 2 cosine squared minus 1, or 1 minus 2 sine squared. So we're going to be using the angle 30. Look at the unit circle, 30 degrees. Which one's easier? Cosine would be root 3 over 2. Sine would be 1/2. Now, it's really not that much harder to do cosine, but sine is easier. So 1 minus 2 sine of 30. Or I could have done 2 Is it squared? I could have done 2 cosine squared of 30 minus 1. So this right here is 2 times 1/2 times root 3 over 2. Right? So these cancel, and I simply get root 3 over 2. That is the sine of 60. Now I do the cosine. What is the sine of 30? 1/2. So it's 1 minus 2 copies of 1/2 squared. Corbin, do you get that? So the formula says 1 minus 2 times the sine squared of 30. That is the double angle formula for cosine. There are 3 versions. It's the bottom one. And I'll do the cosine. It's going to be the same thing. So 1 minus 2, sine of 30 is 1/2, but I need to square it. So what is 1/2 squared? 1/4. What is 2 times 1/4? What is 1 minus 1/2? Negative, or 1 minus 1/2? 1/2. So this equals 1/2. So it, there we go. So this is the cosine of 60. Now, Corbin, let's say you picked a different formula, this one. What is the cosine of 30? Root 3 over 2. So this would be 2 times root 3 over 2 squared minus 1. What is root 3 over 2 times root 3 over 2? Root 9, which is 3 over 4. So this would be 2 times 3/4 minus 1. What is 2 times 3/4? 1/2. Right? And 1/2 minus 1 is 1/2. So you're going to get the same answer no matter which equation you use. But you remember our goal is to find the tangent. So I found the sine of 60 and the cosine of 60 using the double angle formulas. Now I just divide. So root 3 over 2, that's the sine. Darian? Oh, you weren't paying attention. Dang it. Just flip and times. Oh, so you zoned out on purpose. Okay, the 2's cancel. The answer is root 3. Now, couldn't we have found that out an easier way? Yes.
It's a freaking circle.
But you need to understand the formulas because we're about to do something where the formulas start blending together. Well, didn't you learn how to add 6-digit numbers once upon a time?
I don't use that anymore.
Right. So this is just a stepping stone. It's okay. Look at number 7. Half angle formulas. So the half angle formulas are sine of theta over 2 is plus or minus the square root of 1 minus the cosine of theta over 2, or the cosine of theta over 2 is plus or minus the square root of 1 plus the cosine squared, or cosine of theta over 2. Now, the trouble with the half angles is you have to decide whether it's plus or whether it's minus. Okay? You just have to figure out what quadrant you're in. So we said all suckers take calculus. So in quadrant 1, everything's positive. Quadrant 2, the sine is positive. Quadrant 3, the cosine, or sorry, tangent. And then 4 would be the cosine. Okay? Now, look at the formulas. Notice how it says theta over 2. The half angle formula means, is there an angle on the list, on the unit circle, that you can divide by 2 and end up with the angle you're looking for? So we're going to start with the sine of 5 pi over 6. This is number 7. So 5 pi over 6. If you want, you can change it to 300. Oh, sorry. I shouldn't listen to you. So this is 150. Is 150 half as big as an angle that's already on the circle? 300. So we are going to use this formula, and we're going to put 300 in there. Yes. 5 pi over 6 is 150. The angle that you divide by 2 is 300. Right. 300 divided by 2 is 150. Okay. So, Riata, why are we doing this? Because we're about to do something harder, and if you don't know how to use these formulas, it is. Riata. No. She who shall not be named just spoke up in class. Okay. So, we can use 300 to find the answer for 150. But where is 150? What quadrant?
Number 2.
150 is in quadrant 2. So the angle we're looking for is right here, and we want to know the sine of that angle. And in quadrant 2, the sign is always positive. So we can go through and get rid of the subtraction. We know that our answer is positive. Okay, so this is the square root of 1 minus the cosine of 300 over 2. Okay, what is the cosine of 300? So this is the square root of 1 minus 1/2 over 2. What is 1 minus 1/2? A half. What is a half divided by 2? A fourth. So this basically turns into the square root of 1/4. Can we square root 1 and can we square root 4? 1 and 2. So the answer is 1/2. Now that was a really easy one. Okay. Oh, good. 6. 6 is a good one. So number 6. The sine of 165. We need to ask 2 questions. First, what quadrant is 165 in? 2. So the answer is going to be positive. Good. Is there an angle that we can cut in half and get 165? 330. So this is going to equal the square root, the positive square root, not the negative, 1 minus the cosine of 330 over 2. What is the cosine of 330? No, it's root 3 over 2. So we get the square root of 1 minus root 3 over 2 over 2. Yes? Well, you kind of make that decision either at the beginning or at the end. So you either know from the beginning your answer is going to be positive or negative, or at the end you say, wait a minute, I got an answer. Should it be positive? Should it be negative? So the angle being negative doesn't have anything to do with the sides being negative. Oh, I see. Then it would turn to a positive. Yeah. Yeah, so if this was negative root 3 over 2, then you would have minus a negative, which is a plus. Yeah. Okay, so we need a common denominator. What? 2. So this will be 2 over 2, right? So this is equal to the square root of 2 minus root 3 over 2 over 2. Darian? What do you do? Flipping times. So you you flip it upside down, 1 over 2. The top doesn't change, so it's the square root of 2 minus root 3 over the square root of 4. Well, a little bit.
Oh, you can square the bottom.
Because the whole problem is square root it.
So say that again, Malone. So the square root of a over b is equal to the square root of a and the square root of b. So what we do is when we get the square root of 2 minus root 3 over 4, does the top square root? No, it's a mess. But does the bottom square root? Yes. And because it does, we split them. Yes, she who shall not be named. Gotcha. Oh. Okay, where did you get stuck? Oh, okay, we'll have to help you. Yep, this is the answer. All right. Number 5. 5's really easy because the sign of 45 is so simple. So let's not do 5. Let's do 9. Okay. Now, number 9. You have your option. Do you want to do the double angle formula or do you want to do the half angle formula? So, which ones are easier? Double. Doubles are usually easier. Now, this one doesn't end up being too difficult. Now, sometimes it matters. Sometimes you can't do one of them. You can't do a double, but you can always do a half. Okay? So, do you want to see a half? Doubles are pretty easy. Let's do a half. And this one ends up not being too bad. So, is the question you need to ask is, hold on, listen up. Is pi over 3 half as big as an angle that we already know? Yes, 2 pi over 3. So the tangent of pi over 3 is equal to the sine of pi over 3 divided by the cosine of pi over 3. But we're going to use the half angle formula. Pi over, where is pi over 3? Quadrant 1, so sine is positive. Where is pi over 3 again? Quadrant 1, cosine. So they're both positive. The half angle you have to decide if it's plus or minus. Yeah, it is. They're both, any value that's already on the circle ends up being pretty easy. So they're, in this case, they're equally easy, but in general, double angles are easier. Okay, so this will be plus the square root of 1 minus the cosine of 2 pi over 3 over 2, or whatever the degree equivalent is. What formula? You can if you want. I don't like the tangent form. Okay, if you like it, it works. This one's not bad no matter what you do. Oh, thanks. Thanks, Corbin. Okay. No. Okay, yeah. So, okay, use it. I don't ever use it. So, what is, because that angle cut in half is the one we want. You do it with degrees. You guys really don't want to get finished, do you? You keep slowing me down. All right. So 2 pi over 3, the cosine is negative 1/2. So the sine on top is 1 plus 1/2, right, Lexi? Because the cosine of 2 pi over 3 is negative 1/2. So on top, we get 1 plus 1/2, which is 1.5. What's 1.5 divided by 2? 3/4. 1.5 divided by 2 is 0.75.
3/4.
It's 3/4. 1 plus 1/2 is 1.5. 1.5 divided by 2 is 0.75. So we get the square root of 3 over 4, which simplifies to be, good. This is root 3 over 2. Now here, yes, but the cosine was negative, so we added. So this one will be 1 minus 1/2 over 2. What is 1 minus 1/2? 1/2. 1/2 divided by 2? 1/4. The square root of 1/4? 1/2. So this one is 1/2, and when you flip in times, nope, just root 3. High five. She who shall not be named. Okay. Okay, number 17. Okay, now wherever you are, stop. You need to watch 17. These are the hard ones. No.
They're all that hard.
So number 17. We have been given two pieces of information. The cosine of theta is 4/5, and theta is in quadrant 4. So we know that we are over here, right? And that the cosine of theta is 4/5, but cosine is a and h. So this would be 4, and this would be 5. And adjacent is the cosine is the x value. Oh, I see. So this side would be 3. Do we need that? Maybe. We don't know. Yeah, we know it. So number 17 says, what is the sine of an angle that's twice as big? Here's where it gets hard. Alexis? So what is the sine of an angle twice as big? If we're in quadrant 4 and we double the angle, where do we land? Well, what's 270 times 2? 540. What's 360 times 2? 720. So we're somewhere between 540 and 720, which puts us 3 or 4. But the sine in quadrant 3 or 4 is always negative, so my answer is negative. I know that to begin with. Right? So the sine of 2 theta is 2 sine theta cosine theta, right? So we go to the original triangle. What is the sine of theta? Negative 3/5. So the sine is negative 3/5. So 2 times negative 3/5 times the cosine, which is 4/5. And now we just multiply straight across. Yeah. 24/25. Because this is down 3. Right? The y value is down 3. So negative 24 over 25. That's the answer. Okay, let's do number 19. Okay, 19 says the cosine of theta is negative, yes, and theta is strictly between 90 and 180. So the angle we have is in quadrant 2. So we're over here somewhere, and cosine is A and H. So what should we label? 5 is the hypotenuse, and this is negative 4. Yes, the hypotenuse is always positive. So we're in quadrant 2. The x value in quadrant 2 has to be negative because we went left. It told us 90, between 90 and 180. Well, this is always the angle. Well, that's the reference angle. Theta is right here, but the reference angle is right there. Okay, remember the wall, ground, and ladder story? The angle is always attached to the origin. Always. It's always attached to the origin. Because the formula uses this one. Okay, so what about this value here? Positive or negative? The question on number 19 says, what is the sine of theta over 2? So this will answer your question. That is found by doing plus or minus the square root of 1 minus the cosine of theta over 2. So Ashlyn, to answer your question, why do we draw this triangle? This triangle uses theta, and we put theta in here to give us the one that we don't know. We will. We'll have to find that out. We just haven't done it yet. So, and now this is important, if theta is in quadrant 2, and we want to know theta divided by 2, where does theta divided by 2 land? It's got to be in quadrant 1. Because these divided by 2, you get 45 less than theta over 2 less than 90. So any angle in quadrant 2 cut in half will land in the top half of quadrant 1. So if the angle I'm looking for is in quadrant 1 and it's a sine problem, then it's positive. Well, that doesn't always work though, because you don't look at this angle, you look at this angle. No, careful. The cosine is part of the formula. The angle we want is the sine. The answer is a sine problem. So, the formula here is going to be just the plus, not the minus on the outside. It might be. Okay. The answer is the positive square root of 1 minus, what's the cosine of the original? Minus negative 4 over 5 over 2. What is 1 plus 4/5? 9/5. So 1 plus 4 over 5, this would be 5 over 5. The square root of 9 over 5 over 2. Darian, just flipping times. So it's the square root of 9 over the square root of 10. But the square root of 9 simplifies. 3. 3 over root 10. But can't leave the root 10. How about 10? I almost said your name. Nice try. That was number 19. Yes. Number 20. What's your question? You just times by root 10 over root 10.
And then you get the root of 100.
All right, number 20. The cosine of theta is negative 15 over 17. Okay.
So we already know the cosine, so we just have to sine, right?
Well, we want the sine, we want the tangent of theta over 2.
But when you find sine,
Maybe, maybe not. It depends. Okay, shh, Nate. Shh. Okay, we're running out of time, so I want to show you a tangent problem. All right. That's not quiet. Okay, here we go. So, we are in quadrant. We're in quadrant 3, and cosine is A and H. So this would be negative 15, and this would be 17. Doing the quadratic formula, 17 squared minus 15 squared. Square root that. How did I know I'm in quadrant 3? It told me right there. The problem said between 180 and 270. Okay, so this is 8. Okay? Now, we want the tangent of an angle that's half as big. So the tangent of theta over 2, which would be the sine of theta over 2 divided by the cosine of theta over 2. So, where does theta over 2 land? If we're in quadrant 3,
1. Between 1 and 2.
no, so if we divide both of these by 2, I get 90 and 135. 2. So in quadrant 2, the sine is positive and the cosine is negative. So my fraction in the end is going to be a positive over a negative, which is a negative. So my final answer is going to be negative. Okay? So the square root of 1 minus the cosine of over 2 divided by the negative square root of 1 plus the cosine of theta over 2. What is the cosine of theta? What told us right at the beginning. So we're going to plug negative 15 over 17 into both of those.
1 minus 15 over 7.
And then 1 plus 15 over 17. Oh, that's plus. And this one's minus. Okay? So what is 15 over 17 plus 1? 32 over 17. So the top one is 32 over 17 over 2. And the bottom one, what is 1 minus 15 over 17? Just 2 17ths. Yes, Corbin? What's 1 plus 15 over 17? 17 plus 15. All right. So flipping times. So we get the square root of 32 over 34 divided by the square root of 2 over 34. Now, let's not simplify anything. Let's just flip in times. The s- which is the square root of 16, which is 4.
Bless my soul today.
All right, exciting. Okay.